guys, welcome to Learn Extra Live Grade 12 Maths. It's finally your guys' turn. I'm Katleho and this is Megan. How are you, Megan?
Hi, I'm good, and you?
Great, great. So you are one of the top 10 presenters on our search. Please tell us how this feels.
It feels so exciting. I can't even describe the feeling to you. Like, it's crazy. We're here on Maths Mondays.
Awesome. And tell us a bit about yourself.
Oh, what is there to know? I'm studying this year. I'm studying at the University of Pretoria.
Awesome. Me too. High five. What are you studying?
I'm studying biological sciences.
Awesome.
And
That
you?
sounds really good. I'm studying law. Just to say that you asked. So Megan will be joining us today, guys. Make sure that you shoot every single question that you have over to her and she will answer it, guys. She is here to answer your questions, guys. So make sure that you use her to the fullest capacity, guys, because that's what she's here for. And of course, today is Maths Mondays. Hello.
Yeah.
And you guys need to join us on our Facebook page, www.facebook.com/learnextra, and our Twitter handle is @learnextra. We also have in store for you guys, we have this awesome site, guys. You have to check it out. I mean, you really have to check it out. It's really cool. It has notes, it has schedules, it has our shows, it has all you need to know about this awesome show right here. That's learnextra.com/live, guys. Make sure that you learn. It's on the page right now, so make sure that you're checking out the page. And if you're really listening to what I'm saying and you are checking out the page, we have this awesome thing for the month of love. It's called Paying It Forward, guys. It's so that you guys can post your random acts of kindness. Post them on the events wall. Do something nice for a granny, for a little child, for yourself, for your mother, for anyone, guys. And we have awesome prizes. Check them out. It's our Cheetos hamper, guys. Now, I'm looking at these hampers and I'm like, I really want it. I really want those chips right there. Thank you to Simba for sponsoring that. We also have 5 cool CDs from Universal. Thank you, Universal. We have Donald, we have Kaya, we have Unati, we have Malik. All those awesome CDs, guys. We also have our great t-shirt that you guys already know that you guys want. And we have that lanyard and those pens and also a Cheetos notepad, guys. Make sure that you are actually on the page and you're posting your random acts for us, guys, because we will be announcing a lucky winner tomorrow or sometime this week. So make sure that you are listening out for your name. And we're not just here for nothing. We are here to do maths, guys, with Liesel. Hello, Liesel. How are you?
How are you guys doing tonight?
Good, thank you. Did you feel left out by our little spiel over here?
No, it was fine.
Please
I
tell
managed.
Please tell us what we'll be doing today.
Okay, guys, so tonight we're looking at the second installment of Sequences and Series. So what I did last week is I went through most of the theory for arithmetic or linear number patterns. We also had a look at geometric or exponential number patterns, but the questions that we did last week were mostly around arithmetic number patterns and they weren't too difficult. So today our focus is going to be on geometric. There will be some arithmetic number patterns as well, but we're going to have a look at slightly more complicated questions, and we're also going to have a look at the concept of sum to infinity. So just to dust off those cobwebs so that you guys are with me, let's just quickly run through our formulae. So firstly, we have arithmetic number patterns. And let me write an example on the board for you. That would be something like 2, followed by 5, followed by 8, where from one term to the next we add something constant. It could also be that we subtract something constant. So therefore, that constant term that we add or subtract, in this case it's 3, we call the common difference. Right, the common difference. Okay, then we've got the term formula for an arithmetic number pattern. The term formula we will use if once we've identified the number pattern to be arithmetic, if they say calculate the 10th term or calculate the 20th term. Whenever we hear the word term, we're going to be using our term formula over there. Just a quick recap. A stands for the first term, N stands for which term we are calculating. So if it's the 10th term, N would be 10, and D stands for our common difference. So that would be what we add from one term to the next. Right, guys, of course it is true if our number pattern is arithmetic that any two consecutive terms subtracted from each other will give us the same value. In other words, 8 minus 5 gives me 3, and 5 minus 2 gives me 3 as well. Right. Moving ahead then to my sum formula. Whenever I've identified a number pattern to be arithmetic, and I see words such as altogether, or in total, or even just the word sum, then I know that I will be using the sum formula. Again, n is the sum of how many terms we're calculating, a is the first term, and d is our common difference. Now, we dealt with these formulae quite a lot last week, so I'm going to skip over them quite quickly so that we have more time to speak about the geometric number patterns. Right. Now, a geometric number pattern is also called exponential, and from one term to the next, we multiply by a constant ratio. For example, if I have a number pattern that goes 2, 4, and then 8, I can see that from one term to the next, I multiplied by 2. It is true then that the third term divided by the second will be equal to the second divided by the first. So 8 divided by 4 gives me 2, which is my constant ratio, and 4 divided by 2 gives me 2 also. Now, just a quick note, if I'm dealing with a geometric number pattern that's decreasing, something that goes, for instance, 32, followed by 16, followed by 8. It is very clear for me that from one term to the next, I'm dividing by 2. However, our formula doesn't allow for divide, so we have to say what in multiplication is equivalent to dividing by 2, and that would, of course, be to multiply by a half. So 32 multiplied by a half will give me 16, and 16 multiplied by a half will give me 8. Right, so that's important to remember. Again, we've got our term formula. There's our term formula over there. So n would be the term that we're looking for. So if you're looking for the 20th term, n will be 20. Again, a is our first term in our number pattern, and r is the common ratio. So that's what we multiply with from one term to the next. Also, we can be asked to calculate a sum, or sometimes in a sort of word problem, we'll have words like altogether or in total, and then we will use the sum formula. Right. At this point, before I go on to sum to infinity, Katleho, I just want to find out, are people coping? Are they following me so far?
They actually look like they are coping. Hey, Liesel, they're really excited to be here with you
Well,
guys.
then hopefully they watched last
I
week.
know, they did. Most people are like, yay, Liesel is back. I love her. So we know that they are with us today, Liesel.
Right. Okay, guys, now the next thing is the concept of a converging geometric number pattern. Right. The word converge means that it comes together to a point. You can almost liken it to an asymptote if you're dealing with functions. Now, there is only one type of number pattern that can converge, and that is the geometric. So definitely, if you want to check whether a number pattern converges or has a sum to infinity, you have to first establish that that number pattern is geometric. In other words, this has to be true. The third term divided by the second must be equal to the second term divided by the first. Now, that's not the only condition. If you guys look at a number pattern that goes 2, 4, 8, and so on, every time I'm adding a bigger number. So this is not going to converge. It's not going to come together to a point. Now, this brings us to our second condition. Our second condition is that my constant ratio has to be greater than -1, but less than 1, right? And it cannot equal 0. So if I look at an example that I had just now, the one that went 32, followed by 16, followed by 8. This is definitely a geometric number pattern because 8 over 16 gives me a half, and so does 16 over 32. So the first condition has been met. Now, I need to look at my constant ratio. And what is happening from one term to the next? I am multiplying by a half. Remember, I said we have to look in terms of multiplication. Right. So, that means that this number pattern does converge. Now, guys, what that means is if we think about the next term that I add, the next term will be 4. The next term will be 2. Then it will be 1. Then it will be a half. And it will get smaller and smaller and smaller and smaller and smaller until eventually there is a point that we're not going to get past. So we say this number pattern has a sum to infinity. That I can then very easily calculate using this formula. I say that the sum to infinity is 32, which is the first term, divided by 1 minus the constant ratio. And this gives me an answer of 64. Now, what does that mean? It means that even if I keep on summing these terms together until forever, I am never going to get past 64. And that is because the little bit that I'm adding is getting smaller and smaller and smaller and smaller and smaller and smaller. All right. So the first sort of question that you have to be able to deal with when we're dealing with sum to infinity is just to calculate the sum to infinity. There's another type of question, though, also. And that would be something like this. If I say to you, you've got x plus 1 as your first term, followed by x plus 1 squared, followed by x plus 1 cubed. And I say to you, for which values of x will the series converge? Now, for which values of x will the series converge means what values are x allowed to have in order for this number pattern to have a sum to infinity. Now, the first thing that you'll have to ascertain is what is my common ratio? In other words, what do I multiply with from one term to the next? And hopefully it's pretty obvious that from one term to the next, I am multiplying by x plus 1, because I've got x plus 1, then I've got x plus 1 squared, then I've got x plus 1 cubed. So this is what you'll do. You write down, and this is on your information page, that you know, in order to have a sum to infinity, your constant ratio has to lie between 1, minus 1 and 1, and it cannot equal 0. Right. Then you write your constant ratio in the place of r. So I'm going to say x plus 1 must be greater than minus 1, and x plus 1 must be less than 1. Also, x plus 1 cannot equal 0. Now, I didn't ask you in the question for which values of x plus 1 does the series converge. I asked for which values of x. So that just simply means that we now need to solve for x. Easiest way to solve for x in this expression is to subtract x everywhere, because then if I subtract x from the middle term, to subtract 1 everywhere, to get x on its own. And then if I subtract 1 from here, I get negative 2. If I subtract 1 from 1, I get 0. And let me do the same here. And boys and girls, there is my answer. As long as x lies between negative 2 and 0, and x is not equal to minus 1, then my constant ratio will be between minus 1 and 1, and therefore my series will converge. Right, I think we need to get to a break so that we can start looking at the questions. I hope you guys have been looking at the questions from earlier on today. You've worked through them and you're ready for us with all of your questions.
Awesome. Thank you, Liesel. So, guys, of course, a break is well deserved. Although Megan's like, I don't think we should go for a break. I think that we should go right through. Did you enjoy your time here?
It was fantastic. Thank
Awesome.
you. Thank you, Liesel.
It was wonderful to have you, Megan. We'll see you again soon.
Thank you, Megan. Guys, we're going to go for a really short break. During this break, remember, you can go for a rest, but make sure that you come back, guys. Megan's going to be on the page. She's going to be answering everything that you need to answer. She's already on her game, guys, so you need to make sure that you are testing her, rather. See you just now. Welcome back, grade 12s. We are doing sequences and series in Maths Mondays today. Make sure that you guys are asking everything that you need to ask on the page right now, guys. If perhaps you're not understanding something or you're like, please repeat that, I didn't exactly get it, please, guys, shoot those questions off to us because we will only know if you guys tell us. So make sure that you tell us so that we can help you, because this may be our random act of kindness, although it's not random because we're here every week. Make sure that you are still doing your random acts of kindness so that you can stand a chance to win these awesome prizes, guys. So make sure that you are in tune for the rest of the week, whether you take the subject or not, just so that you can hear your name when it gets called out. If it is your name, of course, if you did enter, it might just be your name. So make sure that you tune in for that. Over to you, Liesel.
There was somebody that said, does an arithmetic number pattern have a sum to infinity or converge? I can't, was it Jabulani?
It was Silo.
Silo. Okay. And if not, why not? Now, guys, arithmetic number patterns do not ever, under any circumstances, have a sum to infinity because they don't converge to a point. Have a look at what I mean. If I say, I'll use the easy example, 2, 5, 8. If I work out the sum of the first 3 terms, I will get 15, right? If I then add in the next term, which will be 11, my answer will be 26. And every time I add another term, my number gets bigger and bigger and further away from one point. Now have a look. Now this will be the same for a geometric number pattern where the common ratio doesn't lie between -1 and 1. So if I look at this one, if I add the first 3 terms together, I get 14. If I add the next term, which will be 16, to the 14, so that's the first 4 terms, I get 30. So you guys can see it is not converging or coming together to a point. Now have a look. So these guys, definitely not. But now have a look at the next example. If I look at the number pattern 2, and then 1, and then a half, and then a quarter. If I add the first 4 terms together, that gives me 3 3/4, right? Now let's put in the next term. The next term will be an 1/8. Now guys, an 1/8 is much smaller than a quarter. So now add an 1/8 to 3 3/4 and you'll see it makes very little difference. The next term will be even smaller. 1/16. So what you add gets smaller and smaller and smaller and smaller. So your number pattern, if you add all the terms together, are literally coming together to a point. So conditions. To have a sum to infinity or to converge has to be geometric, and the common ratio has to be bigger than -1, less than 1, and it cannot be 0. Now, there were a couple of you that struggled with that example that I did just now, so I'm going to skip straight on to something that's quite similar to that, and we'll keep the show in keeping with what you guys are struggling with. And here it is. So this is typically what a question like this will look like. For which values of k will the series below converge? So what do the values of k have to be in order for this series to converge or have a sum to infinity? Right. Now the first thing that we need to establish is what is our common ratio? In other words, what do I multiply with from one term to the next? Well, the first term is 2k plus 1 to the power 1. The second term is 2k plus 1 to the power 2. And then 2k plus 1 to the power 3. So to me, it's pretty obvious that I'm multiplying by 2k plus 1. If you're not sure, do this test. Let's take the third term and divide it by the second term. The third term, you don't have to do this. I'm just proving my point to you guys. The third term is 2k plus 1 to the power 3. So I'm writing it out 3 times just to make it super duper clear. The second term is 2k plus 1 to the power 2. Now, if I simplify this, those brackets cancel, and my answer is 2k plus 1. Now, exactly the same thing will happen if I take the second term and I divide it by the first. Okay, so you don't have to show any of this. If it's natural for you what the constant ratio is, then you don't have to stress. So the first thing we do in a question such as this one is we write down the information that we already know. And this is also on your information sheet. This is the condition for convergence. The common ratio must be between minus 1 and 1, and it cannot be equal to 0. So that would be step number 1. The next thing that you will do is you will now replace your R with what is your constant ratio in this particular question, and this was 2k plus 1. So I say now 2k plus 1 must be less than minus 1, sorry, greater than minus 1 and less than 1. And I do the same over here. All right, so the first step is just to write down the definition. The second step is to establish what your R is, what am I timesing with, from one term to the next, and then to substitute it in. Finally, what we're going to do is we're going to solve for our variable. In this case, our variable is k. So this is how I'm going to go about it. I look here in the middle and I say, well, firstly, I only want to have k in the middle. So what I'm going to do, and I'm going to do it everywhere, I'm writing it in a different color, I'm going to subtract 1. That will give me, in the middle, 2k. Negative 1 minus another 1 is minus 2. And 1 minus 1 is 0. But now, guys, I have to solve for k. The question doesn't ask me to solve for 2k. I've got to get k on its own. So I'm going to do that. I'm going to divide by 2. So I'm going to divide by 2. And this gives me negative 1. So what does this mean? As long as k has a value that is bigger than the minus 1, but smaller than 0, this number pattern will converge. But I've also just got to fix up this side. The constant ratio can't be 0, because then from one term to the next, you'll just have the same thing. So this is going to be, so it will just be 0, 0, 0, 0. So I've got to do this condition as well. 2k cannot equal minus 1. So k cannot equal minus a half. Now, if I look at that on a number line, and this is not required, I'm just putting it out there for you guys, it means that k can be, well, there's minus 1, there's 0, and here we'll put minus a half. So k can have any value in that region, but not including minus a half, and then again, any value in that region. And as long as that is true, then the number pattern will converge. Katlego, is this making more sense
I
to our
think this is
viewers?
making more sense to our viewers, hey? They might be a bit quiet, but I think it's because they actually understand.
Right, guys, so just let us know. In the meantime, I'm going to go on to another question. So let's have a look what I've got up here for you guys. Right, now this is quite a tough question. It's not geometric, but it deals with sigma notation, and we haven't really spoken about sigma notation just yet, so I think this is a very good question to talk about. Basically, it says to me that sigma sign means to sum. So the moment you see the sigma sign, you must know that you are going to be using your sum formulae. Either the sum formulae for arithmetic or the sum formulae for geometric. We'll decide just now which one. And this question is asking me, how many terms must I add together? That's why n is an unknown. It says solve for n. How many terms must I add together before I get an answer of 1,715? Now, before you can start worrying about the sum, the first thing you have to do is expand so that you've got your first three terms. So this is what I'm going to do. My little formula says 3k minus 5. And into 3k minus 5, I'm going to start by substituting in 1, because that's what I'm told to do. So I'm going to say 3 times 1 minus 5. And that gives me an answer of negative 2. Then I'm going to go to the next number, 3 times 2 minus 5. And that gives me an answer of 1. Finally, 3 times 3 minus 5, and my answer is 4. So this is my number pattern. I've got negative 2, then I've got 1, and then I've got 4. So once you've done the expansion, it is important to decide whether you are working with arithmetic or geometric. Now, this number pattern is very clearly arithmetic, as from one term to the next, I am adding. There's another easy way to see. Guys, in your little formulae, I'm going to go, if you have something like, let me do this. If you have something like sum in, it doesn't matter, k is equal to 1, where your k or your p or whatever is in the linear. In other words, it's not an exponent. Then you know that you're going to deal with a linear or an arithmetic number pattern. If you have something like this, where your k or your unknown is in the exponent, you are going to have an exponential or geometric number pattern. Those are, of course, the same thing. So that's a very important tip. So I didn't have to think about it too much. I knew immediately if I've got minus 2, 1, and then 4, that I'm dealing with an arithmetic number pattern. Now we're coming up to a break, so I'm going to give you guys a bit of a hint, and you can work on this in the break. We're using the sum formula because of that sigma, and we're using the sum formula for an arithmetic number pattern. This is the formula that you're going to substitute into, boys and girls, and our unknown that we're going to solve for is n. All right. So think about that. Let's just go back to the question one more time. The question wants to know, how many do I have to add together to get an answer of 1715? So in the place of Sn, you're going to put 1715. Now I'm going to give you guys a bit of time to work on that. Over to you, Katlego.
Thank you, Liesel. Wow, they really do like the challenge questions that come during the break. So you guys can actually target that, write it down, keep working on it, and we will see you right after this short break. Welcome back, Mindsetters. It has thus far been such an awesome show, and we need you guys to ask us more questions on the things that you're not understanding. Also, you guys can also help each other, guys. Make sure that you are actually, your full attention is on the page, because you learn so much more when you help another person or get helped by a fellow student. So make sure that you're asking questions and you're equally helping others with the things that you know, guys. Also, Megan is also in the back answering your questions. So say hi to her and maybe just send her the fact that you like her, or maybe that you want to ask her a maths question or how she did last year in her maths. Anything you want, guys, because we're on the page and we're with you all the way. Over to you, Liesel.
Right, guys, so just to recap on the question quickly. The question was asked to us in sigma notation format. We were asked to calculate how many terms have to be added together in order to get a sum of 1715. So sigma always means that we're using the sum formula. Remember what I said just now? If your unknown, like your k, is for instance, like here in the linear, it will be arithmetic. If the k was an exponent, it would have been geometric. So the first thing that you need to do is expand. So I substituted 1 into the place of k, and I got 3 times 1 minus 5, which gave me minus 2. Then I substituted the next number, which is 2n, 2 times 3 minus 5, which gave me 1, and my next term was 4. So now I've got my first 3 terms, and I told you guys it's clearly arithmetic, and we now have to get on with the business of substituting into our formula. Now I've done that, the first substitution. In the place of Sn, I put 1715 because I want to know how many terms must be added together before my answer is 1715. Whenever I'm calculating how many terms, my unknown will naturally be n. So n is my unknown. In the place of a, I put in my first term, and my first term in the number pattern was minus 2. And then in the place of d, I put my common difference, which is what I add from one term to the next. Now, this is all the hard thinking work done. From here on, it's just a bit of algebraic manipulation. So let's get on with that. I'm going to start at the inside of my bracket. So I'm going to say, right, 2 times negative 2 is minus 4. Then I'm going to distribute the 3 into the bracket, so that'll give me minus 3 plus 3n. And that's equal to 1715. Just tidying things up in my bracket. N over 2 gives me 3n minus 7. And all of this is equal to 1715. Now at this point, that 2, the n over 2, could be a bit of a problem. And one easy way to get rid of the n over 2 is just to multiply our entire equation through by 2. So I'm going to do that. Let me use another color to indicate that I'm multiplying the entire equation through by 2. So if I multiply through by 2, I get 3,430 on this side. Please feel free to use your calculator. And on this side, I get quite simply n, because the 2 and the 2 cancel, multiplied by my bracket 3n minus 7. I am now going to multiply the n into the bracket, so I get 3n squared minus 7n minus, and I'm going to bring over to this side, 3430 equal to 0. Now, boys and girls, this is a bit of a nasty quadratic equation. We're not all that good with the horrible factors of 3,430. But remember, you can use your quadratic formulae. Now, because Tamlin in our previous lesson dealt with that sort of thing, I'm not going to go through the motions of putting it into the formula. I'm just going to tell you guys what our answers are. You can then use the quadratic formula and make sure that you get the same answers. So just to write down the quadratic formula, at least in case you've forgotten, x, or in this case it will be n, is equal to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. So remember that a will be the coefficient of n squared, so that's 3. B will be the coefficient of n, so that's minus 7. And C will be the constant term. And don't forget the signs. It's minus 3,430. Right, so I put these in, and I got 2 answers. And I'm going to write them down here. I got n is equal to 35, or n is negative 32 and 2/3. Now, last week we spoke about this quite extensively. N has to be a positive whole number because it's like a place in a race. You can say, oh, I had to add 35 terms together in order to get 1,715. You can't say that I had to add minus 32 and 2/3 term together. That's like saying I've got negative 32 calculators. It's just not quantifiable. So what you have to do is you've got to interpret your answer and say n equal to 35 is correct, whereas the other is not valid. Okay, now before we go on to another question, I need to talk to you guys about some of the questions that we had during the previous break regarding that sum where I said for which values of k will it converge. I'm going to make up another one so that you guys can see that they can all be different. I'm going to say 3p minus 2 is my first term. 3p minus 2 squared is my second term, and 3p minus 2 cubed is my third term. Now, the first thing that you have to notice, or write down at least, is the condition for convergence. The common ratio must be between minus 1 and 1. Guys, you need to know this in the middle of the night. If I wake you up and say, what's the condition for convergence? You need to jump up and tell me this. Also, the common ratio cannot be 0. Because anything times 0 is 0, so then it will just go 0, 0, 0, 0. So that doesn't converge to anything. All right, so that's the first thing I do. The next thing I do is I identify my common ratio, and I'm doing this rather quickly, but you should be able to see that from one term to the next, I am multiplying 2p by 2p minus 2. And then substitute that into the place of r, because that is the common ratio. Now what you need to do is solve for your variable. Now somebody said, why am I always subtracting 1? It just happened to be that I was subtracting 1 in my examples. But in this example, in order to solve to get p on its own, what I will have to do is I'll have to plus 2, because I want to get rid of that negative 2 to get p on its own. So now I'm doing that throughout. So you don't necessarily always do the same thing. That gives me 3p is greater than 1, because 2 minus 1, and less than 3. Now, solving for p, again, I'm going to divide by 3. So I'm going to get that p must be greater than 1/3 or less than 1. Right. So it's not always a case of subtracting 1. I subtracted 1 because it was plus 1 in the middle, but now I have minus 2 in the middle, so I had to add 2. And then just the same thing over here, solve for p. We cannot have our common ratio be equal to 0. And if 3p minus 2 is equal to 0, then this is going to be a problem. Sorry, let me just... 3p is equal to 2. And now I'm going to divide both sides by 3. So p cannot equal 2/3. So if you were to put this on a number line, any value between 1/3 and 1, except for 2/3. All right, Katlego, over to you before we go to our final break for this evening.
Thank you, Liesel. I know you don't want this break, but I think the mindset is like, oh my goodness, my brain is bursting. I need a break. So we're going to give you a break, guys. Take a rest, and we'll see you just now. Welcome back, Mindsetters. I really do hope that right now on the events wall, you guys are already posting your random acts of kindness, guys. Remember to do one every single day. Maybe even post us one that you've done every single day, because this week is Valentine's Day, and Valentine's Day is just all about love. So spread your love, guys. Show your love, and because you will do that, I know you will, you stand a chance to win some awesome prizes from Simba and Universal and Mindset. So make sure that you are busy posting everything that you need to post, guys, because those prizes, I swear, are just absolutely fantastic. And I know that each of you are like, no, I want those chips. Well, post something on the page, guys. Post something on the events page, and we will be drawing out the lucky winner tomorrow. Over to you, Liesl.
All right, guys, so another little bit of sigma notation. We didn't do much on sigma notation last week. So have a look at this question. Instead of giving the expression to you in sigma notation and asking you to calculate something, we now are asking you to write this expression in sigma notation. This is quite an interesting one. Have a look. I've got 1 over 2, then 2 over 3, then 4 over 4, and so on. Now, if at first you test whether it's arithmetic or geometric, you'll probably do this test, term 3 minus term 2, check whether it's equal to term 2 minus term 1. And you'll find that that is not the case. Then you might check whether it's geometric. You'll do the test for geometric, and unfortunately you'll find that that doesn't work either. Now guys, sometimes we can mix things up a little bit, and you need to be a bit of a private investigator and look beyond the obvious. Now if we look at this number pattern over here, I want us to look at the numerator and the denominator separately. So we're looking separately at the top and at the bottom. Okay. Now, if I just have a look at the numbers represented by the numerator, I get 1, 2, and then 4. And then I see, but in fact, these numbers form a geometric number pattern, because 4 over 2 gives me 2, and 2 over 1 gives me 2 as well. So definitely, if I look at the top numbers separately, there's a pattern going on there. Let me have a look at the bottom numbers. Well, this is pretty obvious. It goes 2, 3, 4. So 2, then 3, and then 4. So what am I doing from one term to the next? I am adding something constant. So 4 minus 3 gives me 1. 3 minus 2 gives me 1. So in the denominators, I have an arithmetic number pattern. Now, it's not that hard to represent this in sigma notation. I'm just going to deal with the numerator and the denominator separately. So I'm going to write a general term for the numerator. And I'm going to say, well, seeing as that is geometric, I will use the geometric formula. And I'll say, all right, the first term is 1. And the common ratio is 2, because I multiply by 2 if I just look at the numerator from one term to the next. And that is then my general term that describes my numerator. You can't fill n in. Obviously, if you wanted the 10th term, then you will fill 10 in the place of n. I'm going to do something similar now for my denominator, but because this pattern is arithmetic, I'm going to write down the arithmetic formula and simply substitute in A and D. So the first term is 2. And I add 1 from one term to the next. So that's like that. 2 plus n. So my denominator simplifies to n plus 1. So then if I want to write it in sigma notation, you will do a fraction, and you will put, you don't have to put n, you could even put from p is equal to 1 or something like that. Replace it with a p, but you could, there's no reason why you can't do n. 2 to the power p minus 1 over p plus 1. And you can say you're doing the sum to whatever. You could do the sum to infinity. Maybe that's not a good idea. They don't specify. So let's just say we're going to do the sum to n. So it's often a good idea to look at the numerator and the denominator separately. You can also have a situation in a number pattern where there's alternation. So for instance, the first, the third, and the fifth number form an arithmetic number pattern where the second, the fourth, and the sixth form a geometric number pattern. So look a little bit further than just the absolute obvious. Now, before we go to the next question, which I'm going to put on the board round about now, Katlego,
Hello, Liesel.
how are things going there?
I think things are going super fantastic. Everyone is starting to understand you, which is great. But we wouldn't mind more questions.
Right, so here's another one. We haven't done a question such as this one before either. And this is quite an interesting question. They say, in a geometric sequence, the first three terms are t minus 4, t minus 3, and t minus 1 respectively. Okay. Now, guys, if they give us the first three terms, usually they don't tell us whether it's arithmetic or geometric. But they had to tell us that it's geometric because there is no obvious pattern really from one term to the next. Okay. So if they tell you it's geometric, then you can now assume this to be true, even though you can't make any sense out of the actual terms. Similarly, if they had told us that these three terms form an arithmetic number pattern, now we can't see that it's arithmetic, then you would have assumed that the third minus the second is equal to the second minus the first. So these two things, whenever they're telling you arithmetic or geometric, you will write down the appropriate equation. Very, very important. Okay. So the question says, in a geometric sequence, the first three terms are t minus 4, t minus 3, and t minus 1 respectively. Calculate t and the 10th term. So they want us to calculate the value for t. Now, as long as you remember to write this down, because they told me that it's geometric, and the terms are a bit random, I can't really see what's going on there, you should be fine, because what I'm going to do is I'm now going to substitute into this formula. I'm going to say t minus 1, that's the third term, divided by t minus 3, which is the second term, is equal to t minus 3 over t minus 4. So what I've managed to do here is create an equation for myself, which I'm going to solve. I'm going to solve and find the value of t. Now, the easiest way to solve an equation such as this one is quite simply to cross multiply. So top times bottom, top times bottom. So if I multiply there, I will get t squared. You might want to, maybe our students are going to think I'm working too fast. So let me just...
They always say that.
This is basically what I'm doing. I'm going to be multiplying these two with each other, and I'm going to be multiplying those two with each other. Now you're going to multiply out these brackets. Foiling, we also sometimes call it. So we get t squared minus 5t plus 4 is equal to t squared minus 6t plus 9. Fortunately, our t squareds cancel out, so that's really nice. If I bring all my t's to the left-hand side, and I move my numbers to the right, I get the following. I get that t is equal to 5. So I've managed to calculate my value of t. T is 5, but now I've got to check that it works. So let's go back. If t is 5, then the first term is 5 minus 4, which is 1. The second term will be 5 minus 3, which is 2. And the third term will be 5 minus 1, which is 4. And I'm very happy and relieved this does work. From one term to the next, I am multiplying by 2. I've got a common ratio of 2. So now that you know what your actual number sequence is, you can easily answer the next question. The next question asked us to calculate the 10th term. So pretty straightforward. The first term in my number sequence is 1. The common ratio is 2. And n is 10, so that will be 10 minus 1. And you will put that into your calculator, 2 to the power 9. So let's have a look. 2 to the power 9. And your 10th term will be 512. Now the seconds are literally counting down, so Katlego, unfortunately, we wish we could be here for hours, but we've only got one. Over to you.
Thank you very much, Liesl. Guys, what an awesome, awesome show. Now that you guys are in matric, you now know that there's a lot of work, but nothing that you cannot accomplish without us, guys. I know that you guys are always tuning in. Please help your friends, guys. Help your friends. I know your friends always come to you because you're obviously the smarter kids in your class. Your friends come to you and they're like, oh my goodness, please help us. Tell them to tune in to Learn Extra Live, guys, because this is actually where it's at. And also you can keep helping each other on the page. Keep posting your stuff on the page, guys. The page doesn't run away. The page is just for you. So keep going. And also keep doing those random acts of kindness, guys. The 14th of February is a few days away. Make sure that you do it up to then and beyond, guys. Thank you for joining us today.
Good night.
Great talk. Bye-bye.